Hello, everybody. Happy Sunday. Uh, I have one more item to really talk about to complete the kinds of things the things I wanted to do for this semester. And the item is polymorphism. And we're going to look at it in two parts. The first part is going to be abstract classes. The second part will be essentially multiple inheritance. Now, polymorphism means getting one item that has two or three possible meanings. We've already done some of this. When we overloaded the plus sign or the equal sign or the slash for division, we were giving it several meanings. It was the same sign, we used the same sign, but it had different meanings. Now, we're going to do something like that, but it's a little bit maybe harder to figure out that we're really doing that. I'm going to have one class that has several subclasses. Now, I did this already. In the last video, we had a vehicle, and it had subclasses car and bus. But in that particular case, the vehicle had no method called print. The two subclasses, car and bus, did, but not the class above them. Well, I'd like to fix that. The reason I'd like to fix that is I'd like to be able to combine in one array items that are parts of the same subclass, same class, but are separate subclasses. And if I do that, and I want to say print, and have the computer take which print is the proper one, I need to have print defined for the superclass. So that's how I'm going to try to do this. Now, in the example I went for, I tried to talk about an art. And I'll show you over here. My superclass is art. And art has a funny item in it. A virtual void print equal 0. What that says is that print is a method of art. But print is not defined in art. It's defined in its subclasses, its derived classes. So in the art section, the class art, it's a virtual item. It really isn't there. It's taking up room. It's just space. But in another sense, it really is there because we're going to use it. That's the funny thing about virtual things. They are what we want, but they aren't implemented the way we think they are. So again, what's going on here is print is a method of art. And we can say x dot print if x is of type art, class art. Excuse me. But when we say that, x had better be one of the derived classes, because there are not going to be any objects defined as art. Art is not something we can instantiate. We can't say art X. There can be no objects of type art unless they're of type something that is an art. So we'll see that as we do this. Now you'll notice it has a public, painting, virtual void, print. That's what I want to be able to do. I want to be able to print. And now, pardon me, now I'm in painting, pardon me. And painting is a public art. So it's the class art. I put virtual in front of it. I'm not sure I needed to for what I was doing, but I'll leave it there. It won't harm anything. Painting is going to be a class I can work with. And painting's going to have a print. And when I print from painting, it's going to have lots of items that I can print. I can print a title, a painter, a period. And it has private parts, title, painter, and period. Notice there are none up here in the overriding class. Now, next. Book is also an art class, a derived class from it. And it too has a virtual void print. And it's different, prints different items. And it has different private items. And now in my main routine, I'm going to define a painting, a book, a second painting. You probably know all of these from your DWC. Well, except for Foundation Asimov. That's one of the best science fiction books ever written. Now let's go down. Around Cathedral. That's the third one. There are many of those. And this is what I wanted the whole thing for. I wanted to be able to declare a vector that will have both paintings and books in it. But I couldn't do that. It has to be one class that goes into the vector. So I made the class art. But I can't instantiate art, so I can't put art there. I tried it. No way. So but the weirdest thing is, I can create pointers to the class art. I can't have objects of class art, but I can have pointers to objects of class art. Now, if that doesn't blow your mind, I don't know what does. The point is that the painting and the books are actually objects of type art. So when I point to them, I can point to them as paintings and books, but the system will see that as pointers to something called art, the superclass above them. So I push back. Now I need the ampersand because ampersand is the address of P. And I have to put in the vector the address of the class, of the object, because I need a pointer to the object, so that's the address of it. And I'm setting up the vector here. And now I'm going to print the items in the vector. And here is the polymorphic idea. When I put V0 print, V0 is a painting. Therefore, the system uses this print. However, when I do print 1, that item is a book. So the system uses the other print I've defined, the one for a book. This is called late binding. It says at compile time, we don't know which one it's going to choose. But when it's running, it will look at what kind of object it has in the vector And depending on what kind of object it has, it will pick which print to use. So again, what you can think of is that print has been overloaded. There's a print for a painting and a print for a book. They have the same name, and I can use them in this vector area because a pointer to an art object is a pointer to a print painting or a pointer to a book. And so it will see which one it is, the system will see which one it is, and pick the right print. That's what we mean by polymorphism. There's the polymorphism, that item print has two definitions. And the system picks whichever one it needs based on what it has at the time when it's running. Now I'll run this program, and you can see it picked out the right things, did them the right way. So it works. So I think I'll probably send you, I've already written this into the handout here. You can see I talked about it a little, and then there's the program I had. The biggest things to notice are this item here, and you'll notice also that I use virtual here, and I used it in the other one. And that's the way I did it. This is public art part. This is the main. And there's the output. So that's the first of the two items. The idea of creating a virtual, abstract, pure class, whatever you want to call it. Now this second item is not as straightforward, and I personally find it not enjoyable. Also, I find that I can't find many uses of it in the real world. I looked on the web the last time I taught this course to see if I could find some real-world examples. I couldn't find many. So it's supposed to be extremely important, so I will mention it. Now, the problem is we may have an item, a class of people or groups that belong to two superclasses. The most obvious example is from a college. And let's see, I think I do have that file. I have to bring it up, close the solution here. And that's my diamond example. So at a college, we have people. So I'll have a class person. Now, in that class, every person has a name. I need a get. I need a set. They have a social security, so I need a get and a set for that. They have a birth date. I need a set and a date for that. We can compute their age if we know what the current date is. And we have a private section here that has their name, social security number, birth year, birth month, birth day. And I computed the average there. Now, at the college, there are also employees. And an employee is a person. They have a social security number. But they also have an employee number, a date that they were hired, what type of employment they are, employee they are they hourly or monthly or what? They have a pay rate, and then they have something called protected. Now, there's a reason why protected's there, and I'll mention it in a little while. In fact, I think I may have to go up to the top and change that private up above to protect it. And I have private. And then there's students. Now, students are persons also, and they have a student number. And we have all the information on them. But then there are student assistants. The tutors, for example, are student assistants. They are both employees and students. So they're in two classes. And I can do that. This is a multi-classed item. It has two parents instead of one in the hierarchy of the classes. And there's reasonable setups for it. We have the usual things. And I have printed out, I have the pay rate. And now I'm setting some people, some persons. So I have P, and I'm having an employee. I'm setting that up. I have a student, I'm setting that up. And I have a student assistant who I'm setting up. And then I'm outputting the employee, the student, and the student assistant. But there's a strange item here. A.student. What's this student Cohen doing here? The problem is that the student assistant is both a student and an employee. And both of them inherit a name. They both have a name. And if I just write name there, the program, the compiler, the executor has no idea which one I mean. It's conceivable they could be different. I doubt it. In fact, I'm more sure it wouldn't be. But the machine won't take that as an answer. It says, I have two names. Which one do you want me to get? The one that is in the student side or the one that's in the employee side? Remember, we've used this Cohen concept before when we were defining functions that belong to the class, defining methods. And we have to use it here. If there's two choices, we have to do it. And let's see. Now let's see if I can run it. And it did it without too much trouble. That's the diamond problem. The diamond problem says that we have a class that belongs to two parent classes. And in the two parent classes, there is the same variable, the same name. And if we want to use that variable, we have to pick one of them. So we have to put the name of the parent class, Cohen, in front of the variable. Now, I have that program down here. There it is. There. And there. There's the diamond. That's why they call it a diamond problem. And I've got the whole item here. And I got my results. Now that's the material I made a mistake here too, apparently. You see something didn't get taken. Why? Well, I can point out something to you. The problem is the words private. when we have a class that's derived from another class, it inherits everything that's in the public area, but it does not inherit what is in the private area. The private part is still private. So we have to put protected in instead of private for the things that we really want to be inheritable. There's one other exception too. It doesn't inherit the constructor. So I'm going for rogue. I'm putting protected here everywhere. And now if I run it, hopefully I won't get that same problem. Don't know what happened. I think it couldn't run it because I had the other one running. So let's see. Yeah, now it's still there. Well, I must have forgotten to put in something. I'm not going to belabor the point right now. But this protected is still very important. All right, now what am I going to have you do? I've written out and solved a program for you to work on, homework 24. I have 3 classes. Bank account is to be an abstract class. And it's to have this whole list of items here. And it has methods to get and set each of those. And it has 3 abstract methods: print, deposit, and withdraw. Actually, I think it has 5. I believe I left out it has, I believe it has deduct, fee, and add interest. Now, savings is going to implement those items. It's going to do just what they do up there. In fact, it should have the same name. And then checking's going to be in the same kind of setup. I wrote a starter file to get you so you wouldn't have to type quite as much. In the bank account, I did all the gets and sets. Now, you're going to have to do the defining of the virtual methods. That's 1 line each, and it's not very hard. And you're going to have to decide whether you put protected or private in front of the items here. Then you have to write the classes for the savings and the checking. So you will have to do the gets and sets there, and the real definition of the virtual functions. Then we come down here, and this is a main line to check it out. And it did work for me. So I hope it works for you. And that's my result is down here. I wanted to give you one with the diamond problem also. But it's difficult to come up with one that isn't very, very hard. So what I probably will do is not give you one. I think it's rare enough that we don't have to worry about it. So I'm suggesting, and there's maybe a 0.1 chance that I may change my mind, that this will be the last of the homeworks. At most, there would be one more, which would cover the diamond problem. But if I give that, I'll get it ready by tomorrow. So by tomorrow night, if you don't see another problem, there isn't going to be another problem. So I had originally said at the beginning of the class that we'd have probably 26 homeworks, it looks like it's going to be 24. As I understand it, we have 2 weeks left. I've covered the material in the syllabus. I went over the kinds of concepts you were supposed to have gotten in CSC 103. I added in arrays and vectors. Vector isn't particularly unique to the C++. We talked about and then we talked about the new material in 104. Pointers, classes. And with pointers, I needed something to point, so I used binary search trees and linked list. And with the linked list, we implemented both a queue and a stack. First in, first out, first in, last out. We also did recursion. Now, you're supposed to take those things with you into CSC 225 next semester. And since I'm teaching CSC 225 next semester, you're not going to have much luck getting by with, but we never had that before. Yes, you did. So we will build on that next semester, and we will go over things again. The pointers are something that it isn't trivial picking them up. We want to do pointers both in 225 and in 104 because we want to give you 2 exposures to pointers so that you keep seeing them and get a better feel for them each time. That's where it is at the moment. The next thing I have to talk about is what we're going to do about the little oral test I suggested we have. I'd still like to have it, and it's not going to be something big and difficult. What I'm thinking of doing is just giving you a couple of lines, like something from one or another of the projects, and just saying to you, what does that do? I'm not going to ask you to close your books. The only thing is you can't have an expert there to help you. But I'll have different ones for different times. I'll try to get as many different possibilities as possible. For example, I might show you a for loop, or a for loop of the Python type. I might show you a little loop involving some pointers. We might do a class, and we'll talk a little about inheritance or something. It's possible that you may have to add a few words to something. I may leave something out. But you won't write full programs, and it should not take more than 20 minutes. I don't have time to have everybody do 20 minutes. They're individual tests, and I expect that most of you who have been doing the homework will be able to do them. If you understand the homework, I'm not going to be presenting anything that's beyond what was in the homework. So this is really my way of making sure that you at least have grappled with the homework yourself, because I have no idea otherwise. If you've been writing it all by yourself or have been borrowing it from somebody, this is sort of a way I can check a little bit on that. Of course, I just cannot give you a 1 or 2 hour oral exam. It would be impossible to do that individually for everybody. But we'll talk about when to start that. I'll probably try to get to you by Wednesday on setting up the times for that. We can start this week coming up, or we can start the next week. We have to finish by whenever I have to get my grades in, and I haven't checked that to see just when that has to be. So see you later now. Good luck. Keep working. Bye now.